Okay, so we just learned how to determine if a bond is going to be polar. And so just to refresh, we know if a bond is going to be polar or not based on the difference between the electronegativity values of the two atoms that are going to form that bond. So now we're going to talk about polar molecules. So usually a polar bond is going to make the entire molecule polar. Okay, I've underlined and bolded the word usually because that's not always the case. Okay, so I want you to know there are some exceptions. But for the most part, a polar bond is going to cause the molecule to be polar. So what does it actually mean if a molecule is polar? Okay. So this is what I want you to write down in your notes. So polar, think polar opposites. Okay, so one side of the molecule is going to be slightly negative, and the other side is going to be slightly positive. Okay, so it's just slight. There's not that full transfer of electrons, so you don't have the full positive or the full negative charge, but it means that these electrons are going to be shared unequally. So then the side that you can think of like as winning the game of tug of war, it's pulling the electrons near it. That's the side that's going to become partially negative charged. And again, we diagram this with either this little delta symbol and a negative. And then the side that is losing the game of tug of war, or its electrons are moving to the other atom, it's starting to get this slight positive charge. So again, we can represent that by drawing this little delta symbol with a plus next to it. Or a second way to represent polarity is to use the arrow again. Okay, so the pointy part of the arrow points to the partial negative side. And then this side of the arrow, do you see how it makes a little plus symbol? So that goes over the positive side. So why does polarity matter? So it turns out if a molecule is polar, it helps explain why some substances act the way they do. Okay. So the big one that we look at is solubility. Okay. And so what we know is polar and nonpolars, they don't mix. And so an example you probably are familiar with is water doesn't mix with oil. And that's because one of them is polar and one of them is nonpolar. So in science, we have this saying, like dissolves like. Okay. So write this down. Okay. And so what that means is polar molecules dissolve in polar molecules. Okay. And then nonpolar molecules dissolve in nonpolar molecules. Okay. So that's what like dissolves like means. And so now if we look at solubility, water is polar, so polar molecules dissolve in water because water is also polar. And then nonpolar molecules are fat soluble because fats are nonpolar. Some other reasons that we care about polarity, and we'll look at these properties in our Polarity of Water lab, is it helps explain properties like surface tension. It helps us understand like the melting point and the boiling point of different substances. So either starting today or tomorrow, you will start a Polarity of Water lab, and then we'll look into all different types of properties that are all explained by polarity.